Sorry for the slight delay, everyone. My name is Lucas Meek. I'm a customer success manager based on the West Coast in lovely Redwood City, California. We are here at the 10 o'clock time slot for me, different times for everybody. But we are here to talk with Greg Ryerson about using microbits to demonstrate computational thinking. So in just a minute, I'm going to go ahead and allow Greg to kind of get his presentation started. But please, keep in mind, we will share a parking lot link where you can ask questions and things like that. We'll, answer questions in the chat as well. So Greg, go ahead and take it away.
Great, thank you. So I just posted a couple of links in the chat, and unfortunately, they did not share in the way that they're clickable, so I apologize. I will put them up on the screen in a second as well. Okay. So if you don't mind, there's a bit.ly link there that just goes to a quick Google form. It just lets me know who's here in the room with us. And then there's another link at the bottom there. It's a website called Pear Deck, and it says joinpd.com with the code WJTTDD. So parts of the session today will be a little bit interactive. And if you go to the Pear Deck site, it will allow you to participate by typing in a couple of chat boxes at the times when that becomes appropriate. So I actually just need to switch my screen share. Give me 1 second. I'm just showing the wrong site. As I get set up, my name is Greg Ryerson. I am a grade 7 science teacher in Toronto, Ontario, Canada. And today we're going to be talking about how to demonstrate ideas of computational thinking, particularly computational habits of mind, through reflection. And so this allows us to bring in some student voice into what we're doing as well. So let's have a quick look, see who's joining us today. We've got people from Boston, Austin, Texas, Columbia, all around the US. That's great. I might be the lone Canadian in the room, but that's okay too. And we've got some people who are teaching sort of across the spectrum here as well. Lots of us in middle school, great. That's where I'm going to speak to, some of us in high school. And we're covering sort of the spectrum in terms of where we are along our computer science teaching journey as well. So that's great. Hopefully we'll be able to bring in some information that'll be relevant for lots of different people as we go through the session. And I just put a fun question there about which scale are you, or which bird are you on the scale of bird? And it looks like we're a bit across the spectrum there as well. So I don't know about you, but I'm working remotely at the moment, so I feel like one of those birds that's a little bit more frazzled as we go through the day, but that is okay. All right, so hopefully we've been able to join the Pear Deck site and answer that bit.ly form, and I'll make a start. So I've got 3 things that I want to touch on today in the next 45 minutes or so. We'll talk about these computational habits of mind, and sometimes we may call them dispositions. We'll talk a little bit about the microbit and how we can use that to learn some code. And we'll talk a little bit about the design thinking process. And so rather than learning to code, we'll switch it a little bit and think about coding to learn. And just before we get too heavily into the session, I wanted to take a moment to acknowledge the fact that the land on which I'm situated here in Toronto is on the traditional territories of the Huron-Wendat, the Batoon, the Haudenosaunee, the Mississauga of the New Credit First Nation, the Anishinaabe Confederacy, and the Métis Nation, and is still home to many Indigenous peoples from across Turtle Island. So I would encourage all of you to take a moment and think about the land on which you are, and think about those peoples who had the land before we had it, and work towards reconciliation and truth. So, who am I? Well, as I said, my name is Greg Ryerson. I teach grade 7 science, and the course is a science and technology course here in Toronto, Ontario, in Canada. I am representing the microbit champions today, so we will be talking about the microbit. I'm also a Google certified educator. I'm a National Geographic certified educator, and I'm a certification mentor in the course as well. And I'm a teacher leader with a group called Let's Talk Science here in Canada. So if you now switch over to your Chrome browser, and you go to that Join PD site and you have typed in the code WJTTDD, you should see a question there on the browser that says, what is computational thinking? And there should be a text box there where you can share some thoughts on what computational thinking might be. And I can see that I've got some responses coming in, so that's great. I'm just going to change what's on my screen and we'll have a look at some of these responses here. So we're bringing in ideas of following a step-by-step process, figuring things out, integrating math practices into our thinking. We've got some of those key terms there: abstraction and decomposition and algorithmic thinking. We love it. Math and logic, decomposition, computational concepts, defining a problem and determining a solution. Awesome. I can see that you already are coming in with an idea of what computational thinking is, which is great because that saves me a bit of work there. Solving problems, using logic, recognizing relationships. Absolutely. I agree with all of these points. Using data to make sense of a situation, breaking problems into smaller pieces, thinking like a computer scientist. And I'd actually argue we're actually thinking a little bit like a computer while we use computational thinking. Thank you so much for sharing those thoughts. Today, I want to focus on a specific part of computational thinking, which are what we call habits of mind or dispositions. So yes, there are lots of skills and knowledge that are important, but I think it's these attitudes and these habits of mind that are even more important as well. So computational thinking is essential to the development, not of just computer applications, but we can also support problem solving across all disciplines. So I use this in my science class, and I bring in some technology into that class. But the ideas that we'll talk about today are totally relevant to the humanities and to math and to other courses as well. And I think it's important to note that students who learn computational thinking across the curriculum can begin to see a relationship between academic subjects as well as between life inside and outside of the classroom. So these habits of mind are those things like being able to solve problems and experimentation and thinking like an engineer, inquiring, using design thinking, collaborating well. We've heard these terms before, we've seen these terms before. Today I want to talk about using them specifically in the realm of computational thinking. And so on the screen, I've got a couple of screenshots from some different frameworks. I know there are tons of different computational thinking frameworks, and I often pick and choose where I draw from when I'm talking about this in class. But we can see that ISTE has these ideas of innovation and creativity and collaboration. We can see that K-12 computer science has the ideas of working together and creating a group culture, interacting socially and being ethical in the work that we do. We know as well that these habits of mind and these dispositions come up in the ideas of global competencies and 21st century skills. And so we see these terms all over the place and they get called lots and lots of different things. And I hope that you take away from the session today that it doesn't necessarily matter what they're called, but I think it's really important that we have the conversation about them. So when I present this to my students, this is the shot that I use. This comes from the group called Let's Talk Science that I do some work with here in Canada. And so rather than just focusing on the skills and understandings of computational thinking, our students should be encouraged to think about those habits of mind that they demonstrate while they're coding or while they're doing computer science. Heck, while they're doing the work in any of our classes, they can be applicable to so many different situations. And so they should also consider how these habits of mind carry over into those other subject areas and even into other areas of their life. And so in a little bit, I'll share with you some videos from some of my students about how they think that they've demonstrated some of these habits of mind. So on the screen, you can see that we'll talk about things like persistence and comfort while working with others, being comfortable with trial and error, being flexible, being creative, tolerating ambiguity, dealing with open-ended problems, dealing with complexity, and being inquisitive and curious. And these are some of the most difficult things to teach, but they're so important that we allow our students the opportunity to develop them. So I'd like you to take a bit of time now and go back to your browser where there's another opportunity to share here in the Pear Deck. And I want you to think about one of these habits of mind that you may have demonstrated today and how and where you may have demonstrated it. So some of us may have had to be flexible with planning our schedules around attending a conference on a Saturday afternoon. Some of us we may be here to be inquisitive and curious to learn more. Some of us may have had to be persistent to figure out how to get Zoom to work properly at the start of the day. I'd love to hear which of these habits of mind you think you may have demonstrated today. So we've got some creativity here. maybe dealing with some ambiguity, with some tomfoolery in a previous session. Persistence through technical issues. I know I've certainly been there. I think it's pretty well every day that I will share my screen to the students and somehow mute myself in doing so and launch into my lesson when I say, Mr. Ryerson, you're muted once again, and I persist through it. Inquisitiveness with our Karel offerings. Curious and inquisitive about microbits. That's a good start. Experimenting with ingredients in our cooking. Good, we've got an example there from the real world. Being flexible, being creative. Oh no, sling for a 4-year-old son with a broken arm. That's not good. But I'm glad you were able to be creative and solve it. Comfort working with others. Yeah. Inquisitive, dealing with open-ended problems, being persistent. Great. Creative with how we can apply what we're learning today. Persistent, working on our cell phone during a storm. So hopefully we're seeing that these habits of mind come up in our lives, and they come up in our regular day-to-day situations as well. All right. Let's have a look at some reflections from another student then who can share some of his thoughts about how he's demonstrated these habits of mind. Oh.
So today we did this microbit activity, and I'm going to be talking about why flexibility was so important in this. I know a lot of people are going to do this one. Probably not just for me, but a lot of people needed a flexibility to do well today. We were online, so we had to screen share. It was a little hard to talk to the teacher. We're in class. You could probably come up to us, look over a screen, tell us to do that. We had to learn new ways. First of all, we had to learn what a microbit was and how to use it. Then we had to learn how to download it, and the downloading was a bit of a problem for me. So I had to personally ask classmates, ask Mr. Ryerson, look up on Google, and to see which way to do it. So that's why I think why flexibility for me was such a big factor for today to helping me succeed in this microbit activity. And I'm probably making it sound like this microbit activity wasn't fun, but it was pretty fun. I like this. Probably were to do it again, I would do it.
So that video is from the first day when we introduced the microbits in class. And then a few weeks later, we've been using them a little bit longer. And this student, again, is going to share some thoughts about how he might use these skills outside of the science classroom as well.
The habit of mind that I chose and that I will be talking about today is flexibility and / being flexible. Flexibility is being able to change and adapt to different circumstances. A great example of how I've shown this is through the past year in COVID. At the start of COVID, everyone had to adapt to these weird circumstances. Now, a lot of people knew this was coming, so a lot of people were not prepared. People also lost jobs and many other things. Everyone had to be flexible and adapt to these unlikely changes. This example demonstrates exactly what being flexible is about. For me personally, I'm really new to coding. I don't know almost anything about it. So for me, especially when we had to code at home, I had to be very flexible. I had to learn new skills in a strange circumstance in being at home. I had to be able to learn in a small period of time, which shows this habit of mind and flexibility.
So Ryan there has shared some thoughts about how he's being flexible through the COVID era and how he's been flexible through his learning and through the things that he's done in class, which is really nice to hear. And it's really great to hear him say those things and be confident and positive about those as well. All right. If you head back to your Pear Deck site on your browser, you'll see that there's a quick drag and drop option there where it will let me know how familiar you are with the microbit, and that will let me know how in depth we should go today. So it's looking like we've got many of us who are not particularly familiar, and that's a good thing. That's okay. All right, so I'm going to show you the MakeCode site right now. It's called makecode.microbit.org. And actually, I'll just drop this in the chat as well, because I don't think I typed it in correctly the first time. I apologize. And that one is clickable, so that's a good sign. When you get to the Make Code site, and this is where I do all of my coding with my students, there are sites that allow you to use Python a little bit more readily. I tend to work in here because it allows you to switch between blocks and JavaScript and Python. And so for my students, it gives them lots of available options. I'm going to open a project that I started here and that we were working on in class. And so this is a project that is already being set up. This is a project that I would present to my students as we had put it together. And in this instance, we were building a simulator to show the different states of matter. So solids and liquids and gases. We had talked about that in our chemistry lessons. And now we were demonstrating that and modeling that on our microbit. And so on the left-hand side of the screen, you can see that there's a simulator there that lets us know what we are doing. And the simulator is just like the microbit would be set up. It's got our input buttons, an A and a B. It's got a shake option, which is another input that the microbit can use. And so this is a little bit more advanced code. And this is definitely not somewhere that I would start. If I were starting a code with my students, I'd go to the home page and I would click on New Project. And I would call this a name tag. So this is the first task I always have my students do. In here, you'll see there's lots of different blocks, and I'm going to choose a basic show string block to show my name across the screen. And so when I've put that in there, my name's going to scroll across the screen. And so in 3, 4, 5 minutes, you can get your students to go from never having seen a microbit in their life, maybe never having coded in their life, to immediately seeing success in inputting some code into their program. Now, to have this run on the actual physical microbit itself, there is a bit of a download process, which is a bit trickier, but it does allow for some flexibility and some creativity and persistence as those students work their way through that. So I think microbits are a really great way to start your students working on this. They do have an LED screen on the front. The new version, which is the version 2.0, has a built-in speaker and sound sensor, which is really cool. I only have the version 1s in my classrooms. They don't have that feature, but there's still about 4 or 5 different inputs that you can use. There are 3 pins to attach external components. And so we'll use LEDs, we'll use servos, we'll use motors. And so there's lots of actual computing that the students can do in the classroom. If you are interested, this is the CodeHS course that I use. It's called Introduction to Physical Computing with Microbit. And so through it, there are 3 modules, and the students will go through some introductory activities. They'll do that name tag activity first. We'll get some blinking lights on the screen. And then the second module, we move into more advanced work using some physical components. And so you can see there's a mess of components there on a student's desk in the top picture on the screen. And I had 2 little GIFs, but they don't appear to be playing, but that's okay. So one is a breakout board that has some LED lights that are blinking on it. And the second is using a breakout board to power a servo. And so it gives the students lots of creativity and lots of options to explore as they're doing this code and they're learning to code. And as I say, there's options there to work in blocks, in JavaScript, and Python. And so in class, I tell the students, I work in blocks. That's about all my brain can handle. And you'll probably be more advanced by me at the end. And so they often switch into Java and Python before I do. And I think that's wonderful. I'd like to take the last few minutes of the session and just talk about this idea of coding to learn. So we've learned to code in class. We've done some basic coding. Maybe we've used some microbits. We've talked about these habits of mind that we can embody in our coding, but we can also bring in empathy and design thinking by pushing students to create solutions to problems that they might see around them and use that code then to come up with interesting solutions that could help other people. It's worth noting that our students that are in grade 3 are going to be graduating in 2030. So they're going to be entering into a world that's very different than the world that we entered in once school was finished. I often base a lot of this coding to learn work around the SDGs, the Sustainable Development Goals, because they do provide really interesting platforms for the students to explore problems around the world. Many of us are probably familiar with this process of design thinking, but I wanted to show you where the microbit might fit into this process. And there are a multitude of different images or ways that you could bring this design thinking process into your classroom. I like this one. It shows a nice infinity loop, and it reminds us that the design thinking process is cyclical and can be infinite. When we're looking at a problem, it's so important to empathize and understand how the problem affects other people. And that empathy is one of those habits of mind. as we're computing and as we're learning our coding skills, we can empathize with problems around the world and then bring those coding skills in to help solve them. We can define the problem and figure out what it is. We can generate some interesting ideas. And it's when we get to this prototyping stage where we're creating and experimenting, that's where I like to bring in the microbit. So we've found a problem. We have defined the problem. We've come up with some ideas. How can you now create a solution to that problem using your microbit? How can you solve this problem? So in my class this year, we're exploring the Svalbard Global Seed Vault in Norway. And we're suggesting that it's a bit of a failed structure. Due to climate change, there was a leak and some water got into the vault, obviously endangering the seeds that are stored within. And so I've said to my students, how can you use the coding that you've learned through this course? How can you use your microbit to generate a way to resolve this problem? And so one student has used the microbit as a bit of a pass card with his breakout board. And so once it's slotted into the breakout board, it can unlock the main door so that no one can get in unless they've got the microbit and they've got the code. Really cool way to prototype a solution there. Another student set up a new design for the seed vault that instead of being in Norway, he placed on the ISS. And he used the microbit to control some light displays so that he could optimize the conditions and the temperature within the vault. And so it would show green if the temperature was in the optimal range. It would show yellow if it was a bit too hot or a bit too cold. And it would show red if it was far too hot or far too cold. So he took the coding that he had learned, he took this idea of variables and algorithmic thinking and applied it to a really real world situation. It's really, really cool to see. Some of the other students used the servo motors to create automated doors that would stay open for 5 or 10 seconds, enough time to allow a person to enter and then close again automatically. So to limit that risk of leakage and limit that risk of danger to the vault. One thing that's really interesting is that the Microbit Foundation has a project called Do Your Bit, which is designed specifically around the Sustainable Development Goals and is a great concrete way to bring these into your classroom and show your students how they might do their bit by using their microbits to create a really interesting coded solution. I'm just going to change my screen for a second. I'll optimize the video so that we don't get those weird black boxes that pop up on Zoom sometimes. We'll have a quick look at the Do Your Bit project. Okay, and so while my students and I aren't necessarily using the Do Your Bit challenge in our classroom at the moment, we are using the ideas from it as inspiration as we explore the Svalbard Seed Vault together. So I've got 2 more activities that I'd like to pose to you before we wrap up our session. If we go back to our Pear Deck, there's a question on the screen for you that says, which computational habit of mind would you like to focus on demonstrating during the rest of today's con? So I want you to think about the immediate future for right now. And then think about how you could carry that habit of mind over into the real world as well. So let's model how we might ask our students to think about these habits of mind as well. We saw how some of my students talked about it. We know Ryan there was bringing his idea of flexibility, thinking about the COVID-19 world and how we're flexible there. Which habit of mind do you think you could focus on demonstrating during the rest of today's convention? And how could we bring that into the real world as well beyond there? Let's have a look at where we are here. Comfort with trial and error, students freaking out when they're not doing it correctly the first time. I teach grade 7 boys, and I can tell you that that is absolutely something that I deal with lots and lots of days. Reducing complexity, definitely important in today's world. Tolerating ambiguity, definitely. Dealing with complexity, because technology is always changing and supporting our students. Yeah, I'll second that even from today as well. I've got a few different settings that I use every day in Zoom, and so I was navigating those and navigating the complex world of presenting on Zoom each day. Being inquisitive, finding out what other people are doing, finding new things, totally agree. Comfort with trial and error, being inquisitive, comfort with working with others, dealing with open-ended problems. This is great. I hope that we do feel that we can bring these habits of mind into our work today and into our work outside of the con as well. Being confident, dealing with complexity, dealing with those open-ended problems, sharing our curiosity with our students, absolutely. Being inquisitive. These are all really great things to think about and really great things to bring to our students and to model for our students as well. I absolutely agree. In a minute, I'm going to change the screen one last time, and I'll give you one last question to think about. And the question will be, what's one thing from this session today that you could bring into your classroom as early as tomorrow? You know, we may not all have microbits in the classroom. We may not all be able to use those in the classroom the next day, but the Make Code site is a great way to do some coding and have that microbit simulator there in front of us. I would definitely encourage you all to check that out. I know I use them so regularly in my classroom, and they've been transformative in the way that I deliver content and deliver coding and computer science. But I think more importantly, it's these habits of mind and these ways that we can approach problems that I hope we can bring into our classrooms as well. So I'll change the screen one final time. This is the final question I've got for you. Thank you so much for your participation today as well. I appreciate you being confident and willing to share your thoughts with me, which may not necessarily fall on those habits of mind, but are definitely important. So that's great. Let's have a look and see what we're able to bring forward into our lessons. Directly teaching the habits of mind in an organized way. I think my students are probably so tired of me showing that slide with those habits of mind on it, but it really opens up some great conversations. I love this idea, yeah, of using computers and microbits to solve a real problem. I think when I first brought them into class, we used them. They were a bit gimmicky. They were a little bit fun. But you know, a few years have gone by, and I like the idea of using them to do real things. And so our coding is not just on the side of the science that we do, but it's tied directly into what we're learning as well. I love that some of us are already using microbits and design thinking. I do think the Do Your Bit project is a really cool way to bring it into the classroom because it focuses on the SDGs and it ties in that empathetic thinking as well. It's a really awesome way to bring everything in together. Habits of mind, microbits for sensing and AI. Yeah, microbits do a lot of really cool stuff, and there's actually a lot of things I haven't even explored yet myself. That's great. Empathy. I'm glad some of us have microbits to use. Bring them into the classroom, absolutely. Bring those habits of mind in as well. Yeah. When you're starting that block coding with your students, really talk about those computational habits of mind. You know, we often talk about decomposition and abstraction and algorithmic thinking, which is great, but there's a really great scope for those softer skills as well. So that's cool. Modeling those habits of mind. The virtual microbit is great. Getting feedback from your students is awesome. Wonderful. Pear Deck is another great way to engage your students in a class, especially if you're working remotely. Definitely. Share your projects. Please share your projects with other people. Design thinking. Great. Some really great thoughts there. So Lucas and Rachel and Ryan, I appear to have got a couple of minutes ahead of time, but I've just got one last thing to share. And then if you have some extra points, maybe we'll wrap up a couple of minutes early. But I did want to take time to thank everyone for joining me this afternoon. I know it is a Saturday, and I know in Toronto it is absolutely gorgeous outside. So once I'm done here, I'm logging off and getting some off-screen time as well. But thank you so much for joining. I would love to hear about how you and your students explore those habits of mind. And I'd love to hear about how you bring microbits into your classroom. And so if you do want to stay in touch, my email's there on the screen. My Twitter is there on the screen. And if you do share anything, please tag Microbit Champions and tag Microbit Coding to Learn. It's a great way to bring others into the conversation and connect with others as well. And I think the more that we can share these ideas, the more that we can engage in these ideas together, the more we can all learn and grow from one another. And that wraps up my session. So thank you so much. And CodeHS, thank you for hosting me this afternoon. This was a really great opportunity.
Greg, you were absolutely wonderful. I appreciate your microbit presentation very much. Ryan, if you can post that attendance link again, that would be great in the chat. Everyone, if you can just please click that attendance link. And then Greg, I actually think there are a couple of questions. So
perfect. I'm gonna turn off screen share then, if that's okay.
I'm gonna let Rachel and Ryan ask those questions.
Yeah, great.
Here's a question that I think is a really great one for you, Greg. How do you assess the computational dispositions? It's always hard to take something that's qualitative and turn it into some like quantitative assessment. So what is your strategy for that?
So I don't actually directly assess them. I certainly don't assign a grade to them, but I do a lot of student self-assessment and self-reflection on it. So, I mean, those videos that I showed you of the guys are things that we do regularly. So when it's time to introduce the habits of mind, we'll record our first Flipgrid response and say, here's a habit of mind I think I demonstrated. And when we launch into that project, looking at the seed vault, one of the first questions on the first day is, which habit of mind do you think you can demonstrate and improve upon throughout? And so they'll sort of rank themselves and say, you know, I'm not very confident yet in dealing with open-ended problems. So rather than just saying, I'll code a door to open, I'll look at a more open-ended problem. And it allows them to focus on something that they think is important. And then at the end, there are further reflection questions that say, how did you improve in that skill? Or what could you do next to continue improving? So I don't really assign a number, I don't really assign a grade, but it's a lot of student self-assessment and self-reflection that brings that assessment part into it as well. Great question.
We do have another question that says, are there some straightforward lessons other than the what's on make code? I wonder, is it possible to, Carla, if you're still there, are you able to click the reactions, raise your hand so we can kind of unmute you? Maybe you can, if you feel comfortable clarifying your question?
I actually think I understand what the question is. So on the Make Code site, there are a lot of starter lessons, and they're wicked. And they actually have tutorials that take you through step by step. And then on the Microbit Foundation site, so just microbit.org, there are tons and tons of lesson ideas that are posted on there. And there's lots of ways that take those basic lessons and expand them further. One thing, so as a Microbit champion, I do work alongside the Microbit Foundation to continue to develop those lessons further. So a lot of them right now are pretty basic. A lot of them are very straightforward, but we're working on developing things that are a little bit more advanced and a little bit more involved. I will say that on the Microbit Foundation site, there is a computer science course. Actually, it might be on the Make Code site. I'm happy to find that link and share it out if you wanted to send me an email. But there's a computer science course that uses the microbit as the foundation and builds all those skills in. Or check out the CodeHS course. It really probably will have all the things that you want. It starts really basic and it goes quite far and it digs quite deep.
Yeah, Carla, I think you're unmuted. Did you have a more specific question, or was it just about the kind of places for additional curriculum?
Well, like I said earlier, our school, we just got 120 microbits and we're supposed to use it across the campus. And I'm the lucky one who gets to figure out how to get the other teachers to incorporate all of this. And I can't have everybody, doing the same basic lessons. So it's just me trying to, because I'm not an expert on microbit. I've played around with them and that's it.
Carla, if you wanted to jot down my email and send me a message, I'd be happy to share some thoughts and work through that with you. That'd be really fun. I'll pop it in the chat, Carla.
Mine as well, Carla. I'm always happy to help.
And then one more question, if we have time for that. Is that okay, Lucas?
Absolutely.
Awesome. So Susan asked, are there short explanations of the computational dispositions for the students to refer to? So I know that there's a slide that you like regularly show students. Is there a way that you kind of introduce these to students in a way that is student friendly?
Yeah, so I pull all my information from the Let's Talk Science website. There's so many different computational thinking frameworks that are out there. I find theirs really user-friendly. And so on the site, there's lots of breakdowns that will say, here is what abstraction means. Here is what algorithmic thinking is. And there's little diagrams and pictures, and there's things that are there. The other option is to co-create those with your students as well and say, what do you think this is? And create those definitions together. And that makes them a little bit more meaningful as well. So when we talk about flexibility in class, it takes lots of different routes depending on who's talking about it. Because there are some guys who are really inflexible, and for them, a small change is a great step towards it. There's some guys who really need to push themselves a lot further. So there's an option to be a little bit flexible there in how you define those as well.
If you have additional questions, please feel free to put them in the parking lot. As I said, we will share out the slides to anyone that clicks that attendance link. I really appreciate everyone being patient, taking their time. Greg, you are a saint, and that was an awesome presentation on microbits. Right now we have a 15-minute break, and then we will be back in rooms 1, 2, 3, and 4 for our final sessions, and then a ending with Jeremy in our main room. So thank you all for attending, and enjoy the final session.